So that's sort of a speculative future, but I think it's one that we can achieve if we set the guardrails right. Because there's also a very ugly future where AI leads to capabilities in the hands of individuals that are, like I said, very dual use, and leads to a counter reaction where, in order to handle that, the kind of negative externalities that individuals will have on each other, if we can see through walls or can spy on each other or what have you, it leads to a kind of AI Leviathan.
Join the best in the movement. It's Conservative Conversations with ISI, educating for liberty since 1953.
Welcome back. You're listening to Conservative Conversations with Tom Saruf. I'm joined today by Samuel Hammond, who is the senior economist at the Foundation for American Innovation, where his research focuses on innovation in science policy and the institutional impact of disruptive technologies. He previously worked as the director of social policy for the Niskanen Center, where he remains a senior fellow, as an economist for the Government of Canada, specializing in regional economic development, and as a graduate research fellow for the Mercatus Center at George Mason University. Sam received a BA in economics from St. Mary's University and an MA in economics from George Mason University and Carleton University, and he's joining me today to talk more about artificial intelligence. So Sam, it's great to have you with us. Thanks for joining.
Thanks for having me on.
Before we begin our conversation, I'd like to thank you, the listener, for listening to Conservative Conversations. This podcast is a production of the Intercollegiate Studies Institute, and our mission is educating for liberty. If you'd like to join us in fulfilling this mission, be sure to rate and review this podcast on Apple Podcasts to help us reach more listeners like yourselves. Well, Sam, I'm excited to talk about AI with you, which is something that your work focuses on at FAI. And I think the best place to start would be to have you sort of describe the current state of the fields in AI and some of the basic things that one would need to know in order to have a more in-depth and meaningful conversation about an advanced technology like AI.
Sure. Well, the first thing to understand is artificial intelligence is a bit of an umbrella term. It refers to any kind of approach of making machines think, more or less. And you can think about this being broken down into regular programming. So if anyone is familiar with regular programming, you sort of write an if statement and a then statement, and the program executes in a way that's fully deterministic. You give it a instructions, and it follows those instructions. Then in the 80s, there was another approach to AI called symbolic AI, which the idea was, let's take machines and see if we can give them sort of the ability to reason symbolically. So if we wanted to teach a machine language, we could build that up from the rules of language and specify all those rules. Well, that turned out to not work very well because it turns out language is always evolving and the rules of language are often not fixed. And then later, and really what the current AI takeoff is about, is machine learning. So instead of trying to write down a program or to express intelligence in terms of symbols, you instead take a large amount of data and an algorithm that learns that data and combine those things and have the machine learn how to do a task on its own through a process of training in a way that's sort of very similar to training an animal. So, for example, if you ever taught your dog to sit, you're doing a kind of reinforcement learning where you give it a reward for following your behavior. And some of these models work very similarly, where you give it a task. At first, it's terrible at that task, but you give it a little reward, and over time, it'll get better and better. And so in the early 2000s, there was a lot of breakthroughs where people realized, oh, wow, if we just make these models really big, this is sort of the beginning of deep learning, which is just machine learning with bigger models, that they get really, really good at any kind of task we throw at it. So from image classification, you show the model an image, and it'll tell you exactly what it is, to translation between different languages. And then this really took off after 2017 with this major paper called Attention is All You Need, which proposed a new architecture, a new kind of machine learning model that turned out to be much more efficient. It could work in parallel, meaning you could spread the algorithm across multiple computer chips and they'd all be working simultaneously. And it also allowed the model to learn from context. And so this ends up being very important for language, because if you're trying to predict the next word, it's helpful not to look just at the previous word, but at the previous sentence or the previous paragraph to understand the fuller context. And so those were called transformer models. And those transformer models are the technology that lays behind ChatGPT, but are also being used for like Tesla's self-driving car. Because it turns out if you want to predict the next frame that your cameras are seeing in your car, it's helpful not to look at just the previous frame, but the entire sequence of frames leading up to that. And so here we are with a technology now, like ChatGPT, GPT-4, that is now demonstrating quite remarkable abilities, including multilingual understanding. It can translate between virtually any language. It can code for you. It can also do simple tasks for you, can break down those tasks and work through those tasks. And we're really only just getting started. We call these large language models, but in 10 years, we won't think of them as large. We'll think of them as small.
That's I think it's a very helpful start. I'm curious, what does it mean for a non-human or non-angelic being to actually have intelligence? So what is it? How do you, I guess, what does it mean when we talk about artificial intelligence? I think of intelligence as we have, I guess, the human ability is the ability to self-motion, but also to have reason. Does AI have reason the way humans do, or are we sort of using this language as a proxy?
Yeah, so this is obviously an active area of debate. I can give you my own view. So on the one hand, the way these models are trained, because it's sort of large amounts of statistics over large amounts of data, you can think of the model as a bit of a black box. You give it an input and you request an output, and what goes on in between, they're called the hidden layers of the model. And the reason they're called hidden is because we can see what's going on. We can see how the activations of the neurons in the neural network are lighting up, but we don't really know the kinds of programs that are being computed. You can just sort of look at it happen, and then you get the right answer at the other end. And this gets especially difficult when you have large models like the one behind ChatGPT has a trillion parameters. So a trillion different computations that are taking place every time you ask it to write you a college essay. And so you can say, do we judge its reasoning ability just behaviorally? We can ask it something and see that it seems to have a kind of understanding, or is this just what some people have called a deep fake of understanding? And where I come down on this is that really prediction is understanding. If you can predict something sufficiently well, you have to have achieved a level of competency on the thing in question. And I think this is one of the sort of breakthrough insights with AI, which is the systems end up working very similarly to how our brain works. If you walk into a room and you've been into many rooms in the past, so you sort of have a sense of what a room should look like, where the light switch will be, where how the windows work. So we have a model of what a room looks like. But every now and then you walk into a room where something's a little bit off, and your brain sort of notices that, and you make a little update. So being able to predict what you're about to see very accurately implies a degree of genuine understanding. And one way to think about this is, suppose you were trained on text. So these models like ChatGPT were trained on literally all the text on the internet and then some. And so, at first the models memorize. But after you've seen 1,000 examples of Socrates is a man, all men are mortal, therefore Socrates is mortal, and you've seen many, many versions of that kind of reasoning, it turns out to be a more efficient compression, a more efficient way of storing that representation, to have learned the basics of logic, of syllogistic logic. And then you can have you can store that understanding rather than 1,000 examples of that in text. And so really the upshot here is that human generated text that's on the internet contains a lot of latent information about what it means to reason. And as you compress that information into these models, they extract those patterns and reproduce what it means to reason.
Wow, that's really interesting. Because I asked because you mentioned you train it like you train a dog, and in some ways you don't train humans, but you sort of, right, like with kids, you're sort of forming their habits and reinforcing good things and punishing bad things, and there's value and benefit to that. But that's quite in terms of the black box problem. I'm wondering, I guess we can sort of see that it gets the right answer because we already know what the answer is that we've asked it to provide. But I guess hypothetically, if we don't know how all of the processes are working, and so if we're trying to ask ChatGPT to actually teach me something that I don't know, and it gives me an answer, how much are we able to, I guess, trust? And I mean this not just me trying to figure out what the answer to whatever political problem or whatever personal problem, but if we start outsourcing the science to the AI, and we're trying to like actually advance our knowledge as a people, as humanity, how much can we trust the knowledge or the answers that ChatGPT or these other AIs are giving us if we don't understand the how it's necessarily arriving at its answer?
Yeah.
I mean, that's not necessarily a new problem, but I'm wondering, as we're moving forward, how do we know that it's not going to start giving us, basically wrong information that we're then going to run with, and then it's going to compound very quickly?
Yeah, that's a very, very important question and something that people are actively working on. So you don't want to end up in a world like in Hitchhiker's Guide to the Galaxy, where they ask the artificial intelligence, what's the meaning of life? And it says 42. And you're like, what the hell does that mean? And so even if you have some reason to think that the answer is trustworthy, you want it to at least be interpretable. You want it to be explainable, rather than just taking the output for given. And so this is actually a whole field of research called interpretability research. So these models, the way they're structured, is inspired by neural networks in our brain. The neurons in our brain connect with each other in synapses, and will fire and wire based on our sensory inputs. And these machine learning models are based on very stripped down, sort of mathematically simplified versions of that. And so when you look inside these models, what you're really seeing are a bunch of sort of like a graph, like a social network. Each node is maybe a friend, and each connection is a friendship. You think of it looking like that. And when you put in an input, these connections and nodes are firing on and off. And so there's an active line of research called mechanistic interpretability research, where they're kind of doing digital neuroscience, where they're running experiments on the model and checking which neurons activate, which ones don't activate. Maybe they delete some of the neurons, sort of like how in neuroscience you can learn about what a part of the brain is doing if someone has some brain damage there and they lose some sort of functionality. So there's a huge booming field of trying to understand how the models do what they do. And that's useful both for our own edification of understanding how they work, but also for safety, right? Because if you have a model that's just giving an output, if it's in some kind of decision critical setting, maybe it's doing healthcare diagnostics, like you really want to be confident, not only that the answer is right, but that it's doing some valid kinds of reasoning.
Yeah, absolutely. I remember one of my first ever ISI lectures actually was on this. It was on this theme of science, scientism, and society. It was during COVID. It was an online webinar. It was very cool. But one of the lectures was about the case for killer robots and basically using AI in military. I'm not going to ask you about AI in military, but one of the sort of things he was sort of allaying the fears that a lot of people have, and some of the intuitions we have to, I guess, be afraid of certain AI technologies. And I think my last question sort of was getting at that in some respect. But one of the things he pointed out that has stuck with me, and I wonder if it's still true, is that basically because AI is algorithmic, all of these programs are programs, and so that it's programmed to do certain things and to not do other things. That basically we don't need to really worry about the AI basically developing consciousness of its own, or developing its own will and like defying whatever we tell them to. And I was like, at the time, I was like, okay, great. Then we can take AI and we can go crazy, do whatever, terraform Mars. But I'm wondering if that's still true, especially some of the things that you're saying about neural networks and the ability to actually learn concepts and learn some of the, I guess, the basic building blocks of human reason. I don't know if it's either still not true, just we actually have non-algorithmic AI, or if the ability of AIs to create and code other things and actually have the power to create sort of takes us out of this maybe safety valve, or this view that we'll be safe because of algorithms. Any thoughts on that?
Yeah, so this goes back to my how I sort of opened up talking about these three different phases of trying to make machines think. Traditional programming is strictly algorithmic, strictly deterministic. The program that you write in Python or any of these programming languages will work the exact same way every single time you run it. With deep learning, it's much more statistical. So, there's a trivial sense in which everything is an algorithm, but with these statistical models, you're getting probabilistic behavior. So really nothing is for certain. And even you can test this yourself next time you use ChatGPT. Give it a prompt and then open another window and give it the exact same prompt, and it won't answer the same way twice. Or same with these image models, these more elaborate image models that will generate pictures of, avocados playing badminton or whatever you put in. It will do variations on that every single time, and so it's not deterministic. In some level, it can be made to be deterministic, but only in the trivial sense that really everything can be deterministic at a low enough level. When it comes to the sort of broader societal questions and how we understand, human self-understanding, I think this is simultaneously a scientific and engineering program, but it's also a bit of a philosophical program, because as we build sort of replica minds, things that reproduce the kinds of cognition that to date only humans have had, we learn more about the origin of those phenomena, right? So even today, there's this very active feedback loop between people working in AI and people working in neuroscience, where, for instance, in our visual cortex, really beginning with the retina, there are multiple layers of neurons that work almost exactly the same as what are called deep convolutional neural networks, which are a kind of neural network that are used for vision, for computer vision. And actually, people have discovered circuitry in the artificial neural network that then inspires neuroscientists to look in the brain and discover very analogous kinds of circuits. And one of the striking things that came out even just this week was a study from Meta, for Facebook, their research team, where they showed that they could put people in fMRI machines, like these brain scan machines that they're really only studying like the blood flow and the magnetic activity, electrical activity in your brain. They could show these people an image, and then using the data from the brain, from the fMRI, decode what the person was seeing using one of these image models. So we're at the precipice of mind reading technology, and we should be. It's fortunate that you have to have a gigantic MRI machine to do it, because otherwise, they might replace the courtroom.
Yeah, that would be. I'm trying to be neutral here, because that mostly sounds terrifying, but that would be very transformative, to say the least. But I think something, to go back to what you were saying a couple minutes ago, I think a principle or a question that's of central importance here, and this is true of any tool or technology or institution even, is like, how does this benefit human life, or how does this change or impact or connect to what it means to be a human being in the most robust sense. And so I think probably in this case, a lot of the answer to that question is going to be, it's a matter of trade-offs, as in many cases. Setting the right goals of what human life is and ought to be, the criteria for how to achieve that, what's allowable, what's not, what's desirable, what isn't. So that's a pretty open-ended question we're about to ask. But if you look at the risks and promises of various uses of AI, and it's maybe a little not necessarily the most helpful thing to talk about AI as one singular thing, because it spans into many different facets of life. But what are some of the trade-offs or risks and concerns versus the promises and hopes that AI offers? And how do you sort of, when you're looking at this as an analyst and as a practitioner and someone who's in the field, how are you drawing lines personally and making judgments about that sort of thing?
Yeah, I think it's a really important question. I think it's really useful the way you framed it about how do we make sure this technology, regardless of what it's capable of, augments humanity and complements what it means to be human, rather than leading to some post-human transhumanist future where we're just all like plugged into the machines. because I know people who, for whom that would be the successful outcome, I think I share the intuition that that's not the outcome we want to see. We want to see an outcome where AI makes us more human rather than less. And I think it's going to be a balancing act, right? Because we're sort of breaking the subjective barrier. We're in the same way that our brains are black boxes. Any progress in interpretability research on the AI side will lead to interpretability research on the brain side. So we're really dissolving this barrier, this sort of impenetrable barrier that much of Western philosophy was sort of premised on. And I think that can be quite nerve-wracking. I would point to, on the plus side, obviously once we have systems, and I think we will have these systems by the end of this decade, that have the kind of general reasoning ability. So this is another dimension of this sort of narrow AI that does one thing, like plays chess, and general systems that you can give them sort of any task, or kind of like a McKinsey consultant. They can have a very flexible intelligence. I think we'll have systems like that by the end of the decade that can more or less shadow any human worker, starting with knowledge workers or people who are doing things at a computer, because the robots come later, and can more or less shadow those workers, sort of like a trainee, and pick up and go, after maybe a few hours of shadowing. And when that kind of technology, and we're already sort of seeing glimpses of this in sort of narrower settings. Web development, for instance, is being completely disrupted, right? So if anyone listening to this wants to go and be a front-end web developer, you've missed the boat, because we're at the point now where you can just describe a website, or even take a screenshot of a website, and have systems like ChatGPT design and code the entire thing from scratch. As that technology rolls across the economy through various sectors, and there's some sectors like media, like programming, there are going to be things that are at the vanguard that are sort of more exposed early on. Law is another big one. There's going to be I think a major downsizing, a kind of great repricing in the stock market. Many things are going to transform, and we may have this period of really a return to robust GDP growth, and across so many dimensions, from healthcare diagnostics. If you can, instead of having to wait in line at a minute clinic to see a doctor, you can literally take a picture and show it to ChatGPT, and it will tell you if it's infected or not. This is one of this is one of the use cases people are already demonstrating. It's sort of a doctor without borders at that point, but it's also a lawyer without borders. It's also a financial accountant without borders. This can be truly transformative. On the other hand, general intelligence is inherently dual use. You can't make a self-driving car that only works on blue cars but not red cars, right? Because the ability to drive a car is general. And likewise, these systems, if we build systems that can more or less perform any task at a human level or beyond, it goes beyond just them being trustworthy. We also have to think about, what if people intentionally ask these systems to do malicious or harmful things? I think a scary example of this that I saw just last week was the head of technology for the Iranian military saying that AI would take their fatwa down from 2 years to 5 months. Wow. Fatwa GPT. Yeah. And there are even reports of the fighters in Ukraine using fully autonomous drones, consumer drones, the kinds that you can go buy at Walmart, with a little bit of AI in them to fly themselves and target enemies. So those kinds of things, right now we're on a ramp up in terms of compute. So in terms of the physical computers and hardware and the power of that hardware to drive both the training of the models and the ability to fit the model in a smaller and smaller device, in the same way that our smartphone used to be giant supercomputers 20 years ago. And that curve is ramping up really quickly. We've heard of cloud computing. All the world's cloud, which are basically just giant servers owned by Microsoft and Google and so forth, the entire capacity of the world's cloud data centers are going to double over the next 3 years. The number of companies that are building these models is proliferating rapidly, right? So right now we maybe have 3 or 4 companies that are really at the cutting edge, like OpenAI, Anthropic, Google, and Microsoft being the household names. Next year, I think that's going to 10x. And meanwhile, the companies, the models they're training are also going to be scaling really rapidly. And as these models scale, they often develop new emergent capabilities that are kind of hard to predict. We can predict that they'll get better, that they perform better with scale is highly predictable. But the kinds of new capabilities that emerge will often surprise us. And so, GPT-4 is today's best model. There are models in training right now that are 1,000x larger than GPT-4 that will be out next year, that are multimodal, that do vision, text, audio, and then increasingly have some connection to the external world, so that maybe they can control your keyboard or a browser, or maybe they're embedded in a robot, and you can ask the robot, "Go get me a beer," and it hasn't been explicitly trained for that, but it understands because of this multimodal model. It sort of has a world model of how the world is laid out and what these words mean and what the broader context. So I think this is going to catch a lot of people off guard. But the upside is genuinely impossible to overstate. It's just will be as transformative, I think, as the Industrial Revolution. And to the extent that a lot of modern conservative thinking, it was a kind of reaction to modernity and the kinds of trade-offs with modernity, I think conservatives have a huge role to play in making sure that we get this transition better than the last one.
Yeah, that's. I was going to ask you if there are any historical precedents in terms of a groundbreaking, transformative epoch as what we're about to be seeing. If if all the things that you're seeing will pan out as we might expect. But yeah, it's Conservative Conversations with ISI, and we've had a sometimes co-author of yours, Jon Askonas. He's been on to talk about how technology, innovation, they tend to have an undermining effect on tradition, just because it makes obsolete many of the things that many of the priors that we were taking for granted in the structures. It just completely shatters those. And something new takes place, such that the old principle, the old way of thinking might be obsolete, or doesn't really make sense in the new context. And so I'm wondering, I guess, if you could speak more to how conservatives have a role to play here in emerging technologies and AI, and maybe what we might call like hypermodernity or something like that.
Yeah, so this will be inherently more speculative. But if I want to paint the best picture of sort of what a North Star would be for what, if we can shape policy in a way that will guide us in that direction, what can AI potentially unlock? Beginning with what went wrong with modernity. In some ways, we lived through an era with industrialization of kind of falling opportunity costs on one side of the ledger, right? And so, fewer people are having families because to have a family would forego having a career, right? And so this is, and moreover, as we get richer and richer and we have sort of comparative advantage, it makes less and less sense for, say, the mother to stay at home with the child rather than hiring a nanny, because that mother could be out, working at a law firm or something like that. And so there was also this tendency with the last century to sort of marketize normal family relationships. So if you take those two things, those two aspects are the opportunity cost and the kind of marketization of community life, AI has the potential to unwind a lot of that and bring us back to something that looks sort of neo-traditional, I would say. So you can think of this sort of in micro. We're going to have, I think, this decade, AI tutors that look like, Miss Frizzle and make eye contact with the student and are super engaging. And basically, like in every study, you put the kid in front of it and they'll be at the top of their class. And that could enable a pretty dramatic unbundling from the public education system, in the same way that we saw during COVID a step change increase in homeschooling and learning pods and things, because everyone was forced to stay at home. Once we have the technology to basically relocalize education we could rebundle around new kinds of communities, especially if AI is, dramatically changing the labor market. I don't believe in stories where we're all technologically unemployed, because I think ultimately AI makes us all richer, right? But it means we also maybe all work a lot less, and so those opportunity costs, those trade-offs between having a family or not having a family, go down. Moreover, as we relocalize production, not just things like childcare, but all kinds of things, the need to have these kinds of standard-setting bodies that sort of homogenize society could also wither away. And I've tended to think of this as sort of also peak secularization. So a lot of my academic work was on sort of the economics of secularization, why the U.S. secularized when it did, and I have a really deep interest in sort of social capital theory and how communities come together. You can already see, once we have kind of toasters that can talk to you, that the world may open up to a kind of reenchantment where we start to see a deeper interest in returning to more religious modes of life, in part because we start to understand that there is this like deeper mystery, and even when you have the black box, it's not fully understandable. So that's sort of a speculative future, but I think it's one that we can achieve if we set the guardrails right. Because there's also a very ugly future where AI leads to capabilities in the hands of individuals that are, like I said, very dual use, and leads to a counter reaction where, in order to handle that, the kind of negative externalities that individuals will have on each other, if we can see through walls or can spy on each other or what have you, it leads to a kind of AI Leviathan, right? A digital police state on the China model, and I think there will be countries that do go that route, and what's especially scary about that route is it sort of has an inherent lock-in. Once you've gone digital surveillance police state, it's hard to get out of that, especially once, even today we could have cameras in every street that are constantly being prompted by AI models to say, is anyone committing a crime? Or worse, is anyone thinking wrong thought, or what have you? There will be states that go that direction. So it's incredibly important, both from a conservative perspective, that we draw on that tradition of liberty, but also see the ways that liberty is insufficient, that we can also steer this technology towards more communitarian outcomes.
You mentioned, and I've seen that you've written a bit about this, the idea of AI and Leviathan. I remember there's a TV show I used to watch. I'm sure that's not the only one, but it was called Person of Interest. And this dude coded a machine to basically predict when someone would be in danger. And the machine would basically spit out their, I think, social security number. And then he sold it to the government. And then there was another machine that rivaled. It was very, and then there was a war against the machines. It was fascinating. But I'm wondering, I guess, if you could speak more to the concept of AI and Leviathan, what that might look like, in greater detail, and how we might prevent something like that from happening.
Yeah. So, that's a series I wrote on my Substack, and it really draws on the original Leviathan. So Thomas Hobbes' Leviathan, arguably sort of the originator of political science, social contract theory. He wrote the Leviathan at the end of the English Civil War, at the beginning of the interregnum, when things calmed down. And the argument from the Leviathan was, that the state of nature, mankind's natural state, is to be at war with each other. And it's sort of a kind of proto-game theory, kind of prisoner's dilemma kind of thinking that we can solve that war of all against all by ceding authority to a higher power, to a absolute government that can step in and say, you have your natural liberty, and we draw the line at, stealing each other's property or doing violence on each other. He wrote that book, like I said, at the end of the English Civil War, which itself was in some ways caused by a radical information technology, namely the printing press. So the printing press was invented in the early 1500s, but only really diffused across the countryside into the 1600s. And actually, as a matter of fact, English Parliament, had an ecclesiastical censorship committee that would, if you wanted to print a book, they had to approve it. It was like a licensing board. But once diffusion got to the point where every little tiny town had their own printing press, that became unenforceable. And I think around 1634 or so, the licensing regime just outright collapsed. And overnight, you suddenly had all these new Protestant denominations, Presbyterians, the Puritans, all speaking up against the Church of England. You had this sort of ability, sort of like with the internet, for people on other sides of the country to discover that they're like-minded. And very quickly, within 5 or 10 years, they were in civil war. And the church, the establishment, sort of lost its credibility, lost its legitimacy. And in essence, there was this incredible tumult, a transitionary period. And on the other end, we get sort of modern nation states. We had the wars of religion, and then we discovered, the kind of Westphalian nation state model. And we've been in that model ever since. And so drawing that analogy, if AI is at least as transformative as the printing press, then I think we need to be looking at institutional shifts that are at least as transformative as, say, the shift from feudalism to Westphalian sovereign nation states.
Wow, that's a huge thing. And I mean, that reminds me of one book that was it Revolt of the Public by Martin Gurri, about how the digital public square has, I guess, undermined traditional authorities and created a new structure. And we're seeing a lot of the wages of that. A book I recommend to all of our listeners. We're starting to come to the end of our time. So let me ask, in closing, honing in, I think, on like innovation and policy a bit more, what you would recommend for harnessing the power of AI at a policy level to advance ourselves, technologically and economically, but also some of the other things that you mentioned, spiritually, education, leisurely pursuits, social cohesion. All of those things that benefit humanity in the way that we talked about earlier. What are the sort of things that you recommend would be, recommendations you give to policymakers to help achieve, a desirable future with AI versus an undesirable one?
Yeah, on first order, a lot of my work has been focused on this issue of AI national security and AI and export controls. So the U.S. is, NVIDIA is the big company that makes these chips. And if you want to build these big AI models, you really need their chips, their computer chips. And fortunately, they're a U.S. company. Unfortunately, the actual manufacturing is done in Taiwan at TSMC. And so I think it's of the utmost importance, especially insofar as we see that there's sort of this knife edge that we're on, where we could go the China model of digital surveillance state, or try to preserve and elevate the best of sort of the conservative liberal tradition, that we win that arms race. And I'm using arms race loosely because I don't think it's necessarily strictly military that I'm talking about. I think it's demonstrating the economic model. And if the U.S. can come out of this transition, orders of magnitude wealthier and more powerful, that it's important that we get there first. In other words. And so these export controls that were introduced last year and were just recently strengthened are essentially embargoed China from having access to the most advanced AI chips. And there's more work that can be done there, because China is very adept at getting around these restrictions through subsidiaries, through third countries. And so the ultimate solution would be to have something on the chip itself. So I've been thinking about what are called hardware mechanisms that could have a sort of end user control that basically says this won't work in China. So if China ever takes over Taiwan and they seize all those computer chips, that they just won't work. So that's one area. I think this national security dimension is really critical. The second area of policy that I think is underrated, there are many people talking about sort of safety, licensing these models. I think there's that the debate is pretty saturated. I think there's less attention put into how to diffuse these models in government. And I think there's also going to be this arms race playing out between the private sector and our government, machinery government, our state capacity. And unfortunately, we have a very sort of old old processes, old systems in government. The IRS, for instance, their master file dates back to like the early 1960s. So we're working with a government that has very broken firmware, and if we want to maintain sort of basic government functionality, we're going to need government to be embracing this technology itself, and that can also lead to pretty dramatic downsizing, and potentially heighten the trust in government, because right now trust in government is at a low. But one of the reasons trust in government is at a low is because if you have an IRS agent that is part of the deep state, you don't really know what they're that they have discretion, right? And the more you shift decision making into you have someone at top, someone that we trust that is making the policy, but the people implementing the policy, the more that becomes something that's automated and therefore fully auditable, something that we can actually go look at and trust, then we can both shrink the footprint of government and simultaneously increase its effectiveness at the same time.
Well, I think that's a great note to end on, Sam, so thank you. And I want to use this opportunity to promote to our listeners our third annual American Economic Forum, which will take place on November 1st at the Catholic University of America. AEF is going to focus on the themes and tensions that grip the right concerning economic theory and economic practice. And Sam will be chairing a panel on artificial intelligence with Jon Askonas and with Neil Chilson. Other panels will include immigration and wages, American economic history, and social capital. So you can see that we're taking a comprehensive view at economics and the good life. You'll also be able to hear great keynote lectures from figures like Luke Burgess, Elbridge Colby, Sagar Enjeti, Amity Shlays, and Sohrab Ahmari. And people in the DC area can find more information about this year's American Economic Forum and come hang out with Sam, and I will also be there at our events page at isi.org/events. But Sam, in the meantime, we'll look forward to seeing you then. But if people want to hear more of you on AI and look at more of your work, aside from AEF, where can they look for you?
Professionally, it's thefai.org, and my second best is my Substack is secondbest.ca.
Awesome. I'll link that in the show notes for our listeners. But thanks again, Sam.
Thank you.
And thank you for listening to Conservative Conversations with ISI. If you've enjoyed this episode, be sure to go to our website at isi.org/resources to see all that we offer our members, including the Intercollegiate Review, select modern age articles, lectures, debates, and of course, this podcast. Thanks again for listening. Don't forget to rate and review, and we'll see you next time on Conservative Conversations with ISI.